Alright, welcome to another Algebra 1 video. We're doing 9.3 over 2 days, so we're starting off with the easy stuff first, the stuff with only numbers. So the concept we're dealing with is stuff inside roots. So the square root of 25 is something that's pretty easy to solve. Square root of 25 is just 5. The square root of 16 is just 4. The square root of 9 is just 3. We know some square roots, but what we're looking to simplify is when we have stuff like the square root of 50. So what do we do when we have the square root of 50? Well, we're going to have a process for this. So let's start with a different question. Let's start with something a little easier, like square root of 8. When you want to take things out of a square root, what you need to do is you need to get something that you know the square root of. So if we build a little table of all the things we know the square root of, 1 squared is 1, 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. What we're looking for is if any of these perfect squares here go into 8. And one of them does. 4 goes into 8 twice. And so what we know is we know the square root of 4 times the square root of 2 equals the square root of 8. And the square root of 4 is 2, and so it's 2 root 2. Now that's one way of going about doing this. There's another way to think about this, to do the exact same question, just a slightly different way. And that way is to take the square root of 8 and just prime factorize it. So what goes into 8? 4 and 2. What goes into 4? 2 and 2. And if you fully prime factorize a number, like 8 here, I mean, we could go further with 2 and 1, but that's a waste of time because 1 goes into everything, so we never do that. So just every factor bigger than 1. Now all you do is circle. If there are two 2's, and in this case there are 3 2's, but I can only circle pairs, that's what we're allowed to take out of our square root, and that's why we get 2, and then the leftover guy here stays inside the square root, and we get 2 root 2 this way as well. So let's try another example. Let's do root 52. Alright, what goes into 52? 2 and 26 go in. What goes into 26? 2 and 13. So that means I do have a pair of 2's here. Nothing goes into 13 except 1 and 13. So that's as far as I can go there. I get to take out this pair. So a 2 goes to my outside, and I have a 13 left over inside. Now this was the second method I did before. Let's try to do this one with the first method. So let's see if 4 goes into 52, since 4 is one of my perfect squares. And 4 goes into 52 if you do 52 divided by 4. You get 13. And so root 4 times root 13 is the same as root 52, and root 4 is 2, so you get 2 root 13. So again, a couple different ways of looking at doing the same question. So now let's take a peek at one with a number in front. Let's say you have something like 3 root 48. And you want to pull as much stuff out of this square root as you can. Well, we have this number on the outside, and it's already multiplied by this. So we're going to have to take this into account, but it doesn't actually change our square root simplifying steps, where we try to figure out what goes into 48. So I know 4 goes into 48. It goes in 12 times. And then I know 4 and 3 go into 12. So I know root 48 is the same as square root 4 times square root 4 times square root 3, because 4 times 4 times 3 is 48. I still have this 3. from the original problem, and I can rewrite each of those square root 4s as 2's. So 3 times 2 times 2 times root 3. And this just makes 12 root 3. So notice this 3 in front, all we do is multiply whatever we get to pull out of the square root by that 3, and we're done. So this answer, 12 root 3. So don't be afraid if there's a number in front, you just kind of take it along for the ride. Now let's do one that has a little bit of different of a feel. 2 root 64. Well, the square root of 64 is actually just a number, because 8 times 8 is 64, which means this is just 2 times 8, which means this is 16, and that's it. Okay, let's try another one with a different feel. Let's do 4 root 53. What goes into 53? 1. Well, 1's boring. 1 goes into everything. 2. No, it's odd, so 2 doesn't go in. 3. No. 4. No. 5. No. 6. Oh. Nothing goes into this, which means this is already factored as much as possible, and the answer is just 4 root 53. Now let's just throw one bonus question in here. What happens if you get something like 2 root 3 plus 4 root 27? If you get a question like this, you can actually combine these to make one term. The reason why you can combine these to make one term is if I simplify this second term using the techniques we just learned, then they'll have the same root, which means I can add them together. As is, I can't add them together. If you add these together and you get 6 root 30, you've done bad math. Bad math. Demon magic math. So, we are going to split this guy up. Do any of my perfect squares go into 27? And the answer is yes, because my perfect squares, remember, are 1, 4, 9, 16, 25. And the perfect square that goes into 27 is 9. So 9 and 3 go in, which means this is the same as square root 9 times square root 3 times 4. And square root 9 is 3, so this is 4 times 3 times root 3, or 12 root 3. And now I can simplify this question further by saying 2 root 3 plus 12 root 3 is 14 root 3. You can only add things together if their roots are exactly the same. So to show just a couple more examples of that, if I have 12 root 2 plus 4 root 3, I can't add these together. That's an answer. No extra work required. But if I have 3 root 17 plus 2 root 17, I absolutely can add these together because they have the same insides, and I can get 5 root 17. So you can kind of treat things inside square roots as variables, which is going to lead us into what's coming soon. By that I mean Friday. The video I post Friday, we're actually going to put variables inside. So we're going to take something like 4x squared y and square root this. And that's going to require a little bit more nuance, and we'll be covering that on Friday. You will only have numbers inside your square root for tonight's homework. Questions that look like this. 6 square root 24. And you're just going to have to figure out what perfect squares go into this. Hint 4. Multiply square root 4 by square root 6. Square root 4 is 2. And then pull the 6 down. And 6 times 2 is 12. And you get 12 times the square root of 6. Now you need to make sure you pull everything out. Notice how I didn't check 6, but what goes into 6 is 2 and 3. And 2 and 3 don't have anything in common, so there was nowhere farther to go. That's why I kind of cheated that step. But you are going to have to finish answers like this, pull as much out of square roots as you can, and then we'll be diving forward into more of this come Friday. So I'll see you then. Bye-bye.